Gaurav, sir?
Yes. So do we
So
go?
actually, I think there is some issue. So we can't go live right now, but we can record the session and then we can upload the session on YouTube.
Okay. So won't be an interactive session in that case. It'll be a recording. Fine,
Yes,
fine with
sir.
me. So
Yes.
Kavin, are you okay with that?
Yeah, it works for me too. Yes.
Okay, then please let me know when to start or as you say.
So we can start now. If sir is okay, Kevin sir is okay.
Yeah. Well, you can start, but I'm fine with water.
Okay, so here we go then. Welcome, friends, to this wonderful workshop on augmented reality and virtual reality skills, especially for India Skills and World Skills competition. This is for the shortlisted candidates for these competitions. It is going to be an amazing session, so please make sure you watch this completely. We have very interesting people with you who will be talking about this particular skill, and you will certainly learn quite a lot. So before starting with the session, let me introduce Immersive Skills Network, imsk.net. So Immersive Skills Network is a community started by a team of volunteers from various domains like game development, virtual reality and augmented reality industry professionals, media professionals, and digital artists from South India. And the community has been growing very rapidly. To work and support the industry, the community has been running various programs and educating the industry of best practices and other techniques to help industries, startups, and entrepreneurs alike. The objective of the community is to make a series of industry well equipped with best talent and the best opportunity for the talent to take it forward. Now, let me introduce our expert for the day. Though he is a very well known name in the entire segment, but let me introduce Kavin. Kavin is the co founder and CTO of Aura Studio, where he leads in creating cutting edge social AR and web XR solutions for brands. As an official AR partner of Snapchat, Meta, and TikTok, his work focuses on innovative marketing campaigns, digital try ons, and AR use cases. A self taught developer turned tech entrepreneur, Kavin shares his journey and insights into AR, XR, and digital trends through his personal brand, RB Kavin, on Instagram. His mission is to empower brands with AR and XR technologies, making complex digital innovations accessible and inspiring future collaborations. So let me give way forward to Kavin. Good evening, Kavin. Welcome to the session. Now it's over to you.
Hi, sir. Thank you for the introduction. So, I'm Kavin, as sir introduced. So, today's session is going to be more about the usage of physics engine inside the Lens Studio platform. So, I'll just share my screen to start with the presentation.
Certainly. Before we start with the session, Kavin, can we have a small introduction about how you started your journey? Because the people who are attending this session are the young minds who are getting into the industry, and most of them are very excited to make it big. And I certainly hope all of them will make it big in AR, XR, MR. So, can you give a very, very small introduction how you started your career, and that can be motivating for the candidates who are there, who are listening to this session?
Yeah, that's sure. So, I just started my XR journey when I was in my final year of college, where I was exploring the different kind of tech. As known, like in India, it's usually the tech ecosystem. Mainly, it's the company who gives the candidate the job role they want to. So in the final years, I was decided to like try out what all other creative domains out there, and then I stumbled across AR as a platform, and then I just started exploring with AR and VR as a technology, and then also stumbled across social AR, which was easily accessible for everyone without any restrictions for a certain type of device. Because when I started out, there was an issue where you have to have like a proper high-end device in order to have access to top edge, cutting edge technology in terms of AI. Whereas these social AI platforms were accessible for everyone and it works on every device. And this was back on 2018. And it started out as that, and I got into a social AR based on like a creative tech agency, and then now I run my own studio based out of London where we create these AR experiences for brands for campaigns or marketing campaigns or AR use cases like AR mirrors and innovative solutions. So that's how my journey as a creator turned into like an entrepreneur.
So certainly you made it sound so easy, I guess. And I understand it must have taken a lot of expertise, a lot of hard work, a lot of hours of learning, especially developing your skills, polishing your skills. So I think that is going to be the journey of the candidates who are attending this particular session, who are understanding, trying to learn this particular skill. So it's really great, and I'm really thankful to you, and really hopeful that all the candidates are going to learn quite a lot. So I'll be stepping aside. I'm Gaurav Birla from Media and Entertainment Skills Council, and now I won't be bothering. It's just you and Kavin. And best of luck, guys. Best of learning to you.
Yes, thank
So Kavin, please take center stage.
you. I'll just share my screen. Mm. So I think I need to. It's asking for permission to share the screen.
Requesting host to please provide sharing.
Yeah, yes, sir. This works. So I'll just extend the screen a little bit. Yes. So before we are going to start entering the physics engine, uh, we'll be going with a template, so it's easy for us to see what we are going to work on, and then later on we could start exploring and debugging of like how individual things work. So since like everyone wants to give it a try, I'll be using a template where on the Lens Studio, latest version of Lens Studio, you can go to the template section and select the physics engine section, where you can just download the template and it will take some time for you to load the template. We will just start with this template as a intro, and then because this has all the needed ideas you might get so that you can just get started into using AR like physics engine into your AR experiences. At this point, you would be aware of the basic usage of how to utilize or how to use the Lens Studio platform, but I'll also like go like a little deep into it and then explain how physics can be increase your reach or like increase your experience when you're creating your AR experiences. We're just waiting for the template to load up. Yeah, once you just the app just got crashed. I just open it again. Sorry for the delay. It's like having little tough issues. I'll just share it in a second. It's taking a while to open up. Yeah. So this is how the template looks like, and then it shows you all the possible experiences or possible AR physics stuff that you can integrate into your AR experiences. And to start with, it's like a basic physics system that you can utilize where it reacts based on the shapes and everything. I'll just go one by one to just showcase, and then we'll just go deep into the how each of these particles or each of these systems how things work. And it can include both the heaviness of the objects or like how each physics and everything works. Like in this particular example, the certain types of boxes, one box is kind of considered as heavy and the other box is light. Because of that, it simulates the physics of the real world as close as possible on your AR experiences. So this entirety is going to be, it works on both the front facing camera as well as the back facing camera of the experiences. So it just needs to conduct around like a domain of its own. So I'll just go again like to showcase the different elements with it. These are the constraints, like the different types of bodies which the physics engine has, and then the different types of constraints of it. I'll explain what constraints are and how they are, how they work and everything. Constraints are nothing but just how each objects collaborate with each other. And it also, this template, particularly template also has more complex experiences with multiple objects in it and how to utilize them. It also has like a ray casting based experiences, which you can utilize to create more experience. So I'll just start from the start of this. So yeah, so what I'll just hide this entirety of this entire plane over here so that you can just get an idea. So we are going to work with the back facing camera, but this the setup and everything works the same for either front facing camera or back facing camera. It's just that you need to do the minor tweakings of it. So when I'll just start with the starting. So if you want to access into using a back facing camera, all you need to do in Lens Studio is to just click the object button, and then you can just go to the helper script, and then you can connect to the world object controller. So what this does is this lets you create a back facing camera setup where it creates an object, it creates planes, and it creates the shadow capture and everything. By just turning on this particular, following these particular steps, what you could access to do is you will be able to, I'll just move the camera outside so it's easy, it can render. Yeah. So by just turning on this, adding this exact one click button, you can enable the back facing camera into your AR experiences. So this only works if you're on the back camera. If you, as soon as you just turn to your front camera, all the elements and all the objects just disappears. So in this way, you can create a back facing camera experiences. If you want to add your own models, like this template, what this does is this lets you create a simple 3D model along with a collider, a touch collider. A touch collider is nothing but if you want to click and drag this object around or something like that, that's where a touch collider comes in. And then we'll just make sure the, yeah. And then this also comes with a shadow material where that lets you bake a shadow or like create shadow on top of the AR experience on top of the flows. So this is how you can create a back facing camera experience. And if you want to add your own 3D model, you can just, all you need to do is you can just create or drag and drop the 3D model under this. So in this case, what I will do is I'll just drag a balloon or like a duck 3D model under this. By just dragging and dropping any 3D model, you can just activate a back-facing camera experience, and it sticks to the any part of the flow. For example, if I navigate around and then refresh the experience, the AR just sits on top of the middle of the location. So in this way, what happens is it always sticks to that particular location on a back camera with without you doing much of like the complicated work. Now let's start into the physics systems of everything. So when we are talking about physics system, what we are talking about is called a physics world. A physics world is nothing but, I'll just create a physics world here. You can just check the physics world here. Yeah. So a physics world is nothing but it says the world that physics is going to happen about what it has to do. Like for example, what simulation rate we are going to do the experience, and you can just check the information over here. This says you can create in Lens Studio particularly, you could create multiple number of physics worlds. A physics world is nothing but a domain of its own. For example, let's say a certain world you want to have. I'll just turn on the examples so that you can understand more about it. Yeah. So as you can see over here, a physics world is nothing but it's kind of a domain of its own. In this particular example, you can just see it has two different physics world. One is this is a different physics world, and this is a different physics world. In this, you can control how the gravity and everything works. That's the world of like the physics. It just simply has the properties of like saying like how the physics works. Like for example, in this particular scenario, the gravity, as we know, it's like 9.8 is the gravity number. In this case, it's like 900 and minus 908. Whereas the moment we just change the 908 into like a positive number, what happens is the gravity increases towards the top. The gravitational pull applies the like pulls the object towards the top. That's how you create the inverse of the gravity. Using this materials or using these settings, that's how the gravitational world or the physics world work, where you can tweak these settings and make it work here. For this, I could just go over here and select this particular physics system, where if I just change the physics world to positive and then refresh it, you can just see the physics object just flies towards the top. The reason because the physics is pulling or the object is being pulled towards the top. This is like the inverse of the gravity. Whereas I could just turn it down and then I could just add a little bit of force on the x-axis. If I just do it, what happens is you can just see the object. Uh, this is without it, where the object would be placed on the center of it. The object is placed here. Whereas the moment you add a little bit of force on the x-axis of the gravity, you can just see the object is being pulled towards that side because the gravitational pull is the physics is simulated in a way where the x-axis is also drifting it. As you are aware of in 3D, we have x-axis that is sideways, y-axis in certain objects, certain places, it's up and down is considered as y-axis, and then front and back is considered as the z-axis. So by just playing with this physics system, what happens is this enables the basic rule of the physics world you are controlling on. For example, the same the positive like pull off on the top, I could just add a minus 10. So you might not notice the minus 10 suddenly. That's because it also the physics world also contains how fast an object should pull. Like for example, I could just change it to 100 of the y-axis. In this way, what happens is the physics would be like, or the pull, the gravitational pull would be way less because the force applied towards that direction is little bit of slow. As soon as compare it to like if I just put a 2000 number, the force which the object is moving would also increase. So this is what we consider as a physics world, where a single experience can have a multiple number of physics world in it. So now that we have talked about what physics world are, and we can now go into more details about how physics works or how the physics is it works inside the Lens Studio platform and how it is applicable for the 3D objects. I'll just turn this off now. So now what we are going to do is we are going to create, as you can just see, this is also like a plain, simple plane. I'll just So what we are going to create now is we are going to create a check between the different physics objects in it. I'm going to create like import a simple 3D object. In our case, I'm just going to create a simple cube. As you can just see, because it is under the back camera facing, you can just see the object in the below. So now I'm going to pull this object on the top. Now you can just see this object or any 3D object you have added into the scene doesn't have physics default by itself. The reason being is the physics takes a certain percentage of the performance because of the we have to manually add the physics. In order for us to manually add the physics, we have to understand how physics works. So in general, in Lens Studio mainly, the 3D object works based on the meshes and then the materials applied towards it. As you can see, if you click on any 3D model, it contains a mesh. A mesh is nothing but so different points of vertex in the 3D space that just joins together to form a simple shape. In this scenario where the mesh is actually a 3D model, you can just click on this highlight and then you can just go and check on the you can always go and check on these individual meshes to understand about more details about that particular mesh. Since the cube is the simplest form of mesh, you can just see it has like the size data of the cube and everything is low. As the complexity of the mesh increases, the file size and all the other components of it increase and changes. So now, in order for us to add physics mainly in this, what we are going to do is we are going to add the component. In Lens Studio, as you might have known before, or if you're completely new with this setup, Lens Studio works based on entity component system based. What entity component means is that every component you are creating can be added, that particular object or that particular properties alone can be transferred to another object, and it works like that. It's basically stacking of different information on top of each other. In this particular example, you can just see there is two different entities for this particular 3D shape. That is, we have something called a transform that says the location, rotation, and scale of this particular 3D object in the 3D space. And then we have another component called the render visual. So what the render mesh visual does is it takes the 3D model and it takes the material and it renders it into the scene we are looking into it. In this way, what we are going to do is we are going to add the physics component into this 3D model. For that, what you can do is you can just go and click the add component button, and it has a drop down list of all the possible components you can add into this particular mesh. In our scenario, we are just going to click on the physics and then it shows all the different properties in it. So as we mentioned before, we talked about what a physics world is. So what we are going to do is let's create a physics world. So as soon as you can just see, as soon as I added a physics world, you couldn't see much of any changes in this entirety. It is because the physics world it just says how the physics works and everything, but it doesn't say what this particular cube supposed to do. Because of that, what we are going to do is we also the physics world is added by default without adding it. Because of that, there is you no need to technically add the physics world. So now we are going to delete the physics world because by default, the physics world is added into the scene as soon as you add any physical components. So now we can just see the difference between, there is two different objects. As you can see, there is something called a physics body and there is something called a physics collider. We'll just go with physics body first. What physics body does is, as you can just see, as soon as we add a a physics body into the component, into this particular object, it just turns into a physics and then it just falls down. And the reason why it just keeps falling down is, even if I refresh it, the reason why it keeps falling down is it doesn't know where the ground is. Even though we have the world tracking and everything set up, we don't know what's happening or where the ground is, which is the ground down and everything. That is the reason why the physics object just keeps falling down. In order for that, what we are going to do is we will just turn off the dynamic of the feature of here. In this way, what happens is you can just see even though the physics body is applied, the physics is not falling. What this means is that whenever we have this dynamic object or dynamic being enabled, that's when the physics of it applies. For example, this is where you increase the weight of the object. Like, let's say the object is 10 kgs or something like that. Then we increase it. The reason why we are adding the weight of the objects and everything is that in the physics world, it depends on each other. So if there is 2 or 3 objects that is involved with each other, the weight of it comes in a factor. So a simple physics body applies the physics towards that particular shape. As you can just see the properties over here, there is a lot of different body types. So to just simply put, this physics body is basically a component that lets you add a physics on top of it. Like, the physics here is nothing but the falling of it, but also, since we are talking about physics, it's also talking about the shape of it. Like, for example, if we take an example of a mobile phone, it just falls under the category of a box. But in a box, it falls under like you can just add if you click on this like collider component, you can just see a little bit of a shape over here. So what this does is it lets you visualize the shape of it. So as we are talking about it, any physical 3D model or any shape is basically comprises of a box or a capsule or a cone or a cylinder. So these are the different types of mesh that forms to create like a complicated shape. Even though we could add a custom shape of it, like custom mesh, but we'll just go into how each component works. So as you can just see, as soon as I selected the object of like the shape of sphere, you cannot see that size of it is like, it's because the sphere is created inside of this. So I'll just put it into a box. So I'm also going to create something called a ground component, so that when the object falls, it falls to the ground of it. So I'm duplicating the same exact box, but in this scenario, I'm just going to use this to just pull it down, and I'm going to scale it on the y-axis and z-axis so that it falls as like a ground for us to work with. So now if I just turn on this dynamic option, you can just see the physics is being enabled. This is because it understands what is below and it falls on top of it. Because the ground component doesn't have a dynamic feature enabling it, it just doesn't have that physics, so it doesn't move down. So in this way, what happens is we can build like invisible wall or build a world where the objects navigates within that circumstance. In that way, the world is contains all the physics objects. So as I mentioned about the shape of the physics body, you can just see, because it is a box, the physics changes because of the box. As soon as I just change it into a capsule, if I just refresh it, you can just see this, because of the shape of the capsule, it just has the collision with the bottom of the shape, or like the ground is different comparatively. If I just change it to a sphere, what happens is it's going to have like a different different how it interacts with the body. So to make it even more easier, I'm going to duplicate this box. Now you can just see, as both the boxes are spheres, as soon as it rolls, it starts rolling out. The reason being this, these two physics shapes are because it's a sphere. Whereas if I just change it to a box, you can just see, as it's a box, it just falls down flat. Whereas based on the shape of this object, it just falls, like interacts with the shape differently. If it is a capsule, if I just refresh it, you can just see, as soon as it falls, because it's a capsule, it falls with the physics with that. That is where the physical type of the shapes comes in, where we can just as I mentioned before, every object defines, every 3D model contains of like these simple physics. Where if you want to add your own mesh, like for example, if it is a complicated mesh, if I just I turn off these two and I'll just take in the dark. Yeah. So if I want to enable physics to it, what happens is I could add a simple physics body. But as you can just see, if it adds like a basic shape of like a box, it doesn't interact with it properly because the dark shape is completely different. That's where adding a custom mesh comes in, where you can add the same mesh what is used into this into the mesh category. And then now when we just drop the mesh, I'll just turn on it so that you can just see. So one more thing is whenever we are using a mesh or anything, when there is a lot of poly counts, it is better to turn on the convex mode, which says like it just takes in the basic shape of it and then creates the shape for the collider. So now you can just see as like this is how if a real duct falls, this is how it falls on top of any shape. By just simply adding the same mesh into the mesh component of the body, it adds in the physics matter. Now, let's go into the category of the matter. So what this means is that now we can just see the physics just like the object just falls, but it doesn't have like a proper, it doesn't have like a proper feel for like having like a material to it. That's where the physics materials comes in. Physics material is nothing but I'm just going to add a physics material. So what this material is that it says how it interacts with when two objects collide or interact with each other in physics. How does that particular objects make it feel? For example, it has to have like a high friction. For objects like balls, it has to have that bounciness. If it is like a rubber, it has a certain bounciness to it. If it is like a concrete heavy object that doesn't bounces. So that's where the physics materials comes in. I could just take this object and I'll just rename it to duck. And I'll just add the same physics material towards it. Now that it's added, you can just see it doesn't show much. But as soon as I just increase the bounciness, you can just see the object bounces a little. This is because we are increasing the property of the material when what happens if that objects interact with another object. This particularly says how the object, what the type of object that is. If I just increase it now, you can just see this is interacting as if it's like it's bouncing a lot. Whereas rolling friction, and we can just play with these spring and every settings to make it feel more alive. So in this way, like compared to a default setting where when the object falls, it just looks pale. As soon as we just increase the bounciness, you can just see the object just falls down and it just bounces back as how a real object does. That's where the physics matter comes in. This is under the physics body. So in this, using these basic settings, you can just add any basic shape or like add physics into any basic shape of your experiences. Now that we have talked about what a physics body is, the next component is the physics. I'll just turn this back. The next component is going to be the physics collider. So what a physics collider is, as I mentioned before, we add in the ground, like for example, in certain objects where the object doesn't move, it is going to be static. Rather than us having like adding a physics body and then turning off the dynamic of it, what we could technically do is we can just delete this and we can just add something called a simple collider. What a collider does is it just acts as same way as a normal other like the physics body. But in this case, what happens is in a physics body, the physics is being applied unless and until you just uncheck the enabling part, the physics would be applied. Whereas in a physics collider, it is going to be static. So you could still move this object up and down, and the physics would just work out the same. But in this case, what happens is the object, this is applied for static objects, or this is applied for objects where you don't want, those objects are not going to be moved. since these physics calculations are going to be performance effective on user's mobile, every physics component is going to add up to that performance thing. Because of that, you have to optimize everything. That's where the physics collider comes in. The physics collider just says this is where the wall is, so you don't need to apply physics to that particular wall, but you can just say this is a wall, this is of this shape. So now you can just see, because it's a sphere, if I just drop it, you can just see the duck. When the duck falls, it just rotates because this is under the sphere. The same, the shape type comes in a factor over here too, where I could just convert this to a box. You can also see that box feature here. As soon as we change the capsule or like anything, you can just see the component being here. So if I just change it to a capsule, you can just see it just interacts because it doesn't have like a flat surface. It just slides it down. That's where choosing a perfect shape comes in. So as I mentioned before, for this particular box, we are going to, let's say we are going to add a physics collider. Now, you can just see this object that didn't move, but it was interacting with the duct shape. This is to emulate the real-time physics or like real physics of how it works. By this way, what happens is you can use the physics collider component for the obstacles you are doing it in a game, or like if you're building it in a scenario, it could be the walls, invisible walls. If you don't want the user to go outside a certain boundary, you can just add this simple collider, and then you can just turn off these particular thing. Like for example, when adding a physics collider, you can just simply turn it off, but still the shape of it works. Because of that, what happens is you can just turn off the particular mesh. Because of this, you can create invisible forces or invisible walls around a boundary of it. Or I can just change it to maybe a sphere, and then I'll just change this enable collider so that you can understand where the physical collider is, but you cannot see the mesh. In this way, what happens is you can utilize these features where you can create an invisible boundary so that the object doesn't fall outside it. To give a perfect scenario, if I just change it to like a capsule, you can just see the object just falls down. But what if we don't want the objects to fall down to a certain way? That's where these physics colliders comes in, where you can duplicate the same objects and create a wall outside of it so that the object doesn't fall outside the part. So that is where the physics collider comes in. As we talked before, in physics, there is physics world and physics colliders. The physics collider is basically applies physics to it, but it doesn't apply like make it objects track down. It is basically an object that just stays still, but when the other physics or body just does interact with this particular physics collider, it just shows as like an invisible component there. Whereas a physics object or like a physics body, what this does is it just applies the gravity, it applies the physics settings towards that particular mesh or like the shape, and then it just interacts with the real world. These are the main two components that you have to add into your physical world. Now that we have seen the physics world, like the physics body and the physics collider, we can just look into the other components. I'll just turn on the example so that we can just go through the entirety of what we learned. As we spoke before, you can just see this is an example of enabling and disabling it, where one is the physics is being applied, the other is physics is not being applied. When we just see it, it's just the same settings of what we talked about, where when the physics dynamic is being applied, the physics like engine works, and then it just pulls it down. As soon as the static box is not applied, it is not working. Also, this is where the like as the object of the size comes in. As we mentioned before, when we add the dynamic feature, what this does is, it also has a mass feature to it. So based on how these masses work, it just the physics world work. For example, let's say this particular green cube is actually 2 kgs. That's why you can just see the seesaw, the like the yellow sphere, like the yellow cube is basically falling this side. But what if I just change it to 0? Now if I refresh it, You can just see because it doesn't have any size or anything, it's not moving. So if I just say add 0.1, if I just refresh it, because these two forces, like for example, this light ball is also zero point 0.1 and this heavy box is also 0.1, it is kindly having a balance in it. Because of that, what happens is it's not, the seesaw is not moving. Let's say if I just pick the light box and then make it 0.15. If I just refresh it, you can just see the physics is being applied, and then because of the yellow ball being heavier, it just pulls the other part of it towards the side. In this example, what happens is there is a little bit of another topic that is relying on it for the seesaw to happen. So we will be covering that. But you can just see in this simple scenario, you could just see both the physics body as well as the physics collider over here. Yeah. So basically, the physics body is for these components, where because this example has like an option for you to drag them and drop it, but as you can just see if I just refresh it, because of the heaviness, that's where the heaviness and everything comes on the physics body. For example, for these objects to be not interactive, we will have like add the physics collider component. And then you can just see there is also another component called constraint. That is what we are going to cover next. I'll just go to the, yeah. So as we spoke before, the different types of physics body, that is the box, sphere, the capsule, and the complicated shape, the compound physics. Its compound physics is nothing but combining multiple shapes into one shape. In this compound physics, you can just say, you can just see it's basically a physics body of the simple sphere is there, but on top, under the physics sphere, you can just see two other components of like the box. But the physical, like the compound physics body is nothing but adding multiple shapes to create a shape of it. Whereas these two other components, like be it the sphere, be it the box, it adds like a different shape towards it. So this is an example of how each object interact with each other. As a sphere, it has to rotate, like roll around when it falls. Whereas a cube or like a shape of like a rectangle, it just falls flat. Whereas a capsule just falls and then falls down. That's how each component interact with it. That's where the physical shape comes in. So now we are going to talk about something called physics constraints. So to simply put, what a physics constraint is that it is how that physics object works. It's kind of either like a pull function or like it's kind of like holding a physics on to a single point. It's kind of like that. In the real world, for example, a physics constraint would be, let's take an example of you're taking a poster and you're just putting it on a wall and then you are using a nail to just put it on a wall. Now, what happens is when you try to pull that particular poster down, it is not going to fall down because that particular point on a wall, that like the shape of that particular nail is basically holding on towards it. That's what the constraint is. The constraint is nothing but one point or a multiple point that let's like the determines how the component of how the physics works. In this example, this is like the perfect example of how what I mentioned about where if you're like grabbing on towards like let's say like a cube, and this is how it interacts. Like for example, you take a clip and you put a clip on towards like a corner of a poster, and then it just falls down. And then due to gravity, only that point is being held, where the rest of the point is being like falling down, where it's kind of like balancing on it. That is where the physics constraint is basically. In that same physics constraint, there is like a multiple types of constraint. For example, how the door opens, like the door opens in a certain way. The door opening is also like a constraint where it's kind of revolving around, like it's kind of that motion. And then there is like that's where the multiple different types of physics constraints comes in. Here you can just see the simple physics constraint is nothing but yeah, you can just see a simple physics constraint where it has like a physics body under which we have the constraint. The physics, like the fixed constraint is nothing but it doesn't make the object fall down. For example, if you just as soon as I hide this particular component, You can just see the physics is being enabled. So in this way, what happens is you can utilize these physics constraint for creating an advanced level experience. For example, unless a certain interaction is to be met, the physics would not be applied. That's where these physics fixed constraint applies, where the fixed constraint doesn't let the object move freely. It just fixes the objects to the certain point. That is where the fixed constraint comes in. Whereas the next part is the point constraint. So this is where the poster and the nail example comes in. As the nail is being applied on towards like a particular angle, or if you clip on like a cloth or something on somewhere, what happens is only that particular point is being hanged, whereas the rest of the part of the physics is being applied on the rest of the 3D model. That's where the physics point constraint comes in, where I could just change this point constraint over here. You just simply what you have to do in order for you to add these constraints, all you need to do is take the physics body, and under that as a child, you can just add the physics constraint thing. You can just go to the physics and you can add the constraint and then change the component here. If I just change it to physics, you can just see as soon as I change it to physics, it just changes the way it interacts. If I just change it to point, based on the point of this particular object, you can just see it. Whereas let's say I want to change the point of where the pulling is happening. If I just change it, now you can just see previously the constraint was here and then the pull was from there. If I just go near. Now this is where like a perfect example would look in this chain. If I just move it here, you can just check the point where parallel, you can just see this is the point is being pulled. By just us changing the point of where to be, where the pull of it or like the constraint is to be applied, you can just change the way the physics object interact with each other. This is the point constraint, where a particular point is being constrained on. And then the next part is the next part is the inch constraint. The inch constraint is the same example as like a wall or like as a door, where you have like a rotation movement of it is happening. You can just take the perfect example of you. And this, what happens is, this is more of like, you can just see over here. If I just try to pull it, you can just see it's revolving around like a 2 points, or like it's kind of like based on this particular line, the constraint is working. Similar to how like a door is being like rotates only on like a certain angle. That's how this works, where the physics constraint is attached to these line. Because of that, what happens is if I just maybe change this to this here, you can just see as soon as I just change it, it just rotates towards that. So what happens is in 1 point constraint, it just hangs on to that particular point of the 3D model. In a physics, the inch constraint, the entirety of that particular row based on this object is being attached to the constraint. So this way you can easily create an opening and closing animation, or like the way of like opening and closing shape of the door. This way it kind of act as a spring or act as in that particular shape. I could just change it to this. And then you can just see there are multiple other constraints. Each object has a constraint. Because of that, it acts like as if it's kind of like falling with each other. It's kind of bending towards that particular point. To simply put, it just bends towards to create a shape. That's where the hinge constraint comes in. The procedure is the same, where you have a physics body, and inside that, as a child, you create another empty component and add a physics constraint and then change it. If I just change it to a point, that way it interacts changes. Like, so that's how you can just change between the different components of it. So this is where the inch constraint comes in. Similar to how we created a complicated shape, custom shape for the shape of the physics body, we could recreate the same. We could combine all like multiple of these components to create like a different way how it enables. For example, you can just see in this basic example, the top is basically the top of the shape is basically uh, like the like fixed constraint. Because of that, you can just see as soon as we interact with it, pull with it, it doesn't changes. Whereas the bottom of it is similar to the point constraint, where as soon as you pull or do something, you can just see it just being pulling on the top. That's where it is. Let's say if I just go to it here and then go over here, you can just see it's a point. If I just change it to an inch, you can just see the way it enables. Like You can just see if I just pull it, now it just rotates at that particular thing. It doesn't always like move like a point constraint. If I just change it to a point, if I just change it to a point, it you can just see it over here, like it just has its own path. Whereas as soon as we just change it to an inch, the motion is only on this angle. The other way, wherever we just pull it, the motion is always uh, related to that particular constraint. Using this, you can combine multiple constraints to form a complicated constraint for the particular shape of. So this is all the basic component you would ever need to create a basic physics system in your AR experiences. The same template you can just go through, where you can just see even an advanced setting where this contains all the components we spoke about. Like for example, this contains the basic fixed constraint, where as soon as you tap on the screen, the constraint is removed and then the object is being formed, and then it interacts with it. So this goes off like how you can use the basic shapes. Also, as we talked about, the shape of the walls is basically a physics collider because it did not do it. Like basically by combining physics collider for walls and then the object as excuse objects like individual objects that we need to apply physics on as the physics body in it, and then the constraint to just hold them. So this is how you could create like a complicated physics environment without changing anything. Let's say I want to create like the have physics on both of the things. Like for example, I'll just pick the rubber duck. Yeah, I'll take the rubber duck and apply this material towards it. And then I'll just go here and increase the bounciness. If I just refresh it, if I just stop it, you can just see because of that adding like the little bit of bounciness, we can add more interactability and more functions or make the experiences more fun. So you can just mix and match with these setups to create more complicated scenes. And also, you can, if you are interested in learning more about complicated physics, what you could do is like go on towards it and understand how it works. As you can just see here, this particular template has all the needed physics you need to understand. For example, this has the physics constraint for the hanging of it. This is, you can just take these examples of understanding how the physics works and why you're using it. For example, this scale example, what this does is it just adds like a constraint. Yeah. Here you can just see this is the box, like for example, if I just travel you can just see this is like a normal box. As soon as this particular object is being scaled up and down. Yeah. So you can just see over here, what we are doing is this is a physics collider. By just scaling the objects up and down, you can make the physics move up or down. Similar to it, you can just play with these multiple components to create more engaging or more fun experiences. If I just turn this on, you can just make sure you can just see the invisible wall is on. Like as a collider is basically, you can turn it on directly and then you can just see this being the invisible wall being added or something like that. By just chaining these different components into the object or into your scene, you can make it more complicated experience. It also, as we mentioned about the raycasting, raycasting is also the script example is also there that you can utilize to as like one of the main components of any physics engine is the collision event. A collision event is nothing but what happens. A collision event is nothing but what happens when two objects, like certain two objects, just collide with each other or like interact with each other. That will enable us to say either if it is like a coin between it, like the interaction between a coin and the user, then we have to run a script, like a run something where if you user collects a coin, if user touches a coin, what happens is the score increases. That's where the physics collision event comes in. A collision event says like, let's say an ant is a collider. If an ant touches a coin, the collision event would be called, saying a script would be called. In that script or in this component, you can just say if this is being added, you can just increase the score of the entire game and then delete this particular component. That's where the physics collider comes in order for you to access the physics collider, what you could do is you can use the behavior scripts. A behavior script is nothing but it's like a default script that you can download directly in Lin Studio, where you can just by clicking over here, you can just select under the helper script, you can just click install the behavior script. A behavior script is it's kind of like a template script that is provided to you, where you can just say the type of collision you want. Like if you want something to happen if the user taps it, that particular script, like the particular thing would just be called whenever the user taps on the screen. That whatever function response type you want, it will be called. Similar to it, what you can do is you can create like a physics event in it. So I'll just create a new entire setup here. So now let's say I want to say whenever the duck touches the ground, I want to print a message or I want to do something. What I'm going to do is I'll just take the duck and I'm going to add the physics behavior script into this. And then now in that behavior script, the trigger event, I'm going to make it physics collider event. Now I want to add which collider I want to check on. So I could just say, I could just do the duck. In this way, what happens is whenever the duck is collides with or something, I can just go to the response and say, print a message. So now every time in this, you can just see on the logger here, every time the duck falls down or has any collision, you can just print a message or do interactions with it. This is how you use the physics engine in the gaming world, where you can, in this particular example, I'm just only printing it, whereas you could just animate a video or like animate a or audio, like animate the 3D model, or you can change the texture. You can just, if whenever an object touches it, let's say whenever the object falls, I want to move a certain objects or something like that. Similar to that, you can utilize this particular behavior script, and then you can use it to basically create whatever you want, response you want. Like for example, let's say apply force. Whenever this particular duck touches the ground, I'm going to turn on the, just check it box. Yeah. I'm just going to make this a physics body. So yeah. So what we are going to do is when this particular duck falls, I'll just go and make it down so that it's on the ground. Yeah. So when this particular duck falls, I want this ball to be bounced back or add a force towards. So in this way, what I'm going to do is I'm going to do the physics in that apply force. Like what apply force does is it adds a particular force to it. Like for example, pulling or pushing was considered as a force. Or if you want to lift an object up, that is kind of considered as a force. So I'm going to like click and drag that object into this location. By this way, what happens is whenever this physics, the object falls down, I'm going to create like an impulse or like a force. And there's under the force also, you can just say the rotation or like the force can be applied on the rotation or the position, or you can just change the type of force. Like for example, if the force needs to be continuously applied, that is making an object always like going against the physics or like the gravity of it. That would be there. We are like going to like change that impulse, like we are going to like add a little bit of force. You will just put 100. You can just see as soon as the duct falls down, because of this, the object 3D object, you just added a force. Using this basic collision event, you can create more interactive experience. If you're writing your own script, you can utilize this collision event to maybe run something different. in this particular example, we just saw how to add we added a little bit of force to the place to just create the diversion or like the impact of it. Similar to that, you can utilize this physics collider to make it more impactful or create more experiences. So these are the basic systems in physics you would need to know before adding physics into your AR experiences. I think that is all for this session, where uh, you can just go to get this template directly from Lens Studio, and you can just use this video as an example and then go and explore with the different settings, and you can just always explore with it. I think with that saying, this session comes to an end of related to how you could utilize Lens Studio's physics engine on your own AR experiences.
Yeah, Kevin.
Yeah, I think that's it. I think the session was that just covers up all the physics related things.
Okay, great. So thank you.
So we can close the session, I guess, Payal.
Yes, sir, we can.
Oh, thank you, Kavin. It had been wonderful sharing this information with the participants who are there. And we'll be basically sharing this session as a recorded video over the channel. And since there are no participants live, so we don't have any questions or any kind of things to be discussed further. So, again, I would like to thank you on behalf of Media and Entertainment Skills Council. It has been wonderful for you to support us. And same, I would also like to thank Ajay for being on the session with us. So, thank you, everyone. Thank you, Payal.
Thank you so much, sir. Thank you, Kevin. Thank you, Ajay.
Yeah. Thank you all.
Bye.
Bye.